Hey everybody, today we're going to be looking at finding the area of composite figures, something we've done a little bit in the past with circles, but we're going to take it a little bit further with some different shapes today. So in this figure here, we can see that we need to find the area of the shaded region. We have a square that is 10 inches by 10 inches, so we can tell pretty easily that would be 100 square inches. We would have 10 rows of 10 inches each, right? So then we have to remove this triangle. And to find the area of a triangle, we use area equals 1/2 base times height. So we just plug in what we know. Area equals 1/2. Our base is 4, and our height is 4. So we could just multiply across. 1/2 times 4 is 2. 2 times 4 is 8. So the area of the triangle is 8 inches squared. Then to find just the shaded area, we would just subtract, and we get 92 inches squared. Okay. Down here, this is a problem that you've probably seen before when we were working with circles. We need to find the area of the shaded region. So first, I'm just going to find the area of the rectangle. We would do 14 times 33, and that gets us 462 square feet. Now for our circle, if you remember, the formula for the area of a circle is pi times radius squared. They give us the radius, so we can just plug in what we know. Let's substitute in. We know that pi is a number, so it's always going to be that 3.1415 blah, blah, blah. 4 squared is 16. So here's the point where I've got a calculator that has the pi button. I'm just going to do 16 times pi on my calculator, and that will tell me the area. And that will get me something around 50.265 blah, blah, blah square feet. So if I want the shaded area, that's the rectangle minus the circle. So let's subtract that 50.265 blah, blah, blah. And we end up with 411.7345, and it will go on forever. So you would either be told use 3.14 for pi, or you could be told don't round for pi, use the pi button, and then they'll tell you what place to round to for your answer. And we still need our unit, square feet. Now we may get something a little more complex like this one. This one looks like kind of like two squares overlapping each other, right? So we could do this a couple different ways. Over here, I have just drawn the figure out so we can kind of break it up and see. I could break it into 3 rectangles and then find the area there. I've got 3 by 5 and I get 15. 2 by 8 gets me 16. And 3 by 5 gets me 15 again, so I can add them all together and get 46 in yards, square yards. Or I could go back to this diagram, how they've got that kind of overlapping corners. I could find the area of a 5 by 5 yard square, which is 25 yards squared, right? I have another 5 by 5 yard squared. And then they overlap right here. So I would need to remove one of those corners that overlaps. But how do I find the measurement of that square? I would need to remove it once. Well, this is 3 yards, and this whole side has to be 5. So I know that this is 2. Same thing here. I've got 3 yards. The whole thing is equal to 5, so this must be 2. So the area of this inner square is 2 times 2, or 4. So I would do 25 plus 25, and then subtract 4 square yards one time. Does it match up with what we got previously? Sure does. Here's part 2 of some more of our composite shapes. Here you see we have this kind of a rectangle shape with semicircles onto either side. And let's think about what we know. We know this rectangle is 14 yards by 9 yards. So we could quickly figure out what the area of that is just by multiplying them. We get 126 square yards. Okay, well now what about these two semicircles? Well, the distance from here to here is 14. The radius is here to here, right? So that has to be 7. It's half of the diameter. We know that the area of a circle is equal to pi times radius squared. And we know our radius is 7. 7 squared is 49. So if we just plug in 49 times pi, substitute that in, we get, I'm going to round to the 10th place, 153.9 square yards. Now, that would be if this were a whole circle. This is half of a circle. So this circle would be half of that measurement. But we also have, I'm sorry, I called it a circle. This semicircle would be half of that measurement. But we have a semicircle over here, and it has the same diameter, which means it has the same radius, which means it must have the same area. So this is equal to that. We can add them together and get this area. 2 half circles would make a full circle. We add them together and we get the total area of 279.9 square yards. Last, let's take a look at this shape. This figure is an excellent example of why you can't always rely on your figures to be drawn to scale, because this side of the trapezoid is labeled as 15 inches. But down here, this is labeled as 11 inches. So technically this isn't drawn to scale, but we can still figure out the area. We know that this side and this side are going to be equal to each other. So we have 11 inches. So then we have to find the average of the two bases for our trapezoid. We would do 15 plus 11 equals 26. Then 26 divided by 2 equals 13. So that's what we're going to use as the base when we find the area of this shape. We would do 13 times 4 to get the area. We're treating it like that rectangle because it is a quadrilateral. And we would get 52 square inches. Now the rectangle down here, it's pretty straightforward. We just need to do height times the base. And we would get 38.5 square inches. Add the trapezoid to the rectangle, and we get a total area of 90 5/10 square inches.